Hello. Oh no, how come I went live? I don't want it to go live. Five. Hello?
Shortly.
Minutes back.
All of our agents are still helping other callers. Please stay on the line and the next... Wait while I transfer your call.
Trash. Thanks a lot. gosh. Are people just reading the message on Schoology? Because stupid ITV. System overload for sending out a message. I guess all 100,000 kids or 700,000, whatever number of kids that we have, they're all getting messages from the teachers right now. Gosh. Is this thing even working though? Hello? Hey, Omar. Okay, let's see how many last second lags. What is this? 7-second lag. I can't put up the link till I'm closer. Patreon, yeah, that's hilarious. Did you guys get a message, or did you guys just see the announcement on Schoology? Oh, the message came out? Okay. We're going to go over slope fields and then how to solve them to get a general equation for the slope field. Well, not slope field. For a particular equation, for a particular solution. The problem is this live stream's going to be like super long because I'm waiting for people to show up. I think it's just 8 people. This is like the highest count I've had. My 11 o'clock live stream, since the message didn't go out, had no one there, so I was just talking to myself. And then at 1 o'clock, I see the message pop up. Mr. Code live streaming now. Thanks, Omar. The problem is I've been since 9 o'clock I've been doing videos and answering questions back and forth, so I don't really have time to do a 2-hour that 2-hour window. I'm just trying to keep up. I'm also teaching one or two of Miss Yagi's classes till the administration tells me what they want to do. Okay, let's see. Alright, I guess we can start. Okay. I'll delete this, I'll trim off this whole section of 23 minutes of nothing happening. Here we go. Thanks for joining us, guys. We're going to go through slope fields, followed by, after we do slope fields, we're going to go ahead and try to solve this general equation. So your worksheet today kind of looks like this. We're going to separate and solve what we can. And I was going to use our AP classroom, and I'll give you guys some more assignments on that once I figure it out. Okay, so we talked about slope fields last time in class before our last test, and we said the idea of a slope field is that we're just drawing slopes, which are little tiny little rays or little lines, say. So looking at all these points here, each of these points are values we're going to plug in for x and y. And we did this in class, and we're just doing it again, just so we have recording of it, yes. So let's say this point is, let's do something kind of off. Let's say this is 2, 1. So we plug those values in for x and y. So dy over dx, which is a way of saying slope. The x is 2 and the y is 1. And remember the slope, our rate of change, or our change is rise over run. So we'll just draw a little line, rise 2, 1, 2, and run 1. And that's our little slope. Probably maybe go 1, 2, and 1. A little sharper. Over here is 2, 2. So it's 2 divided by 2. That's my dy over dx. And that'll give us 1. So rise 1 over 1. Over here is 1, 2. That means my dy over dx is 1 over 2. So we rise 1, we run 2. Over here is 1 over 1. Darn it. 1 over 1, dy over dx. So we rise 1, and then we run 1. So we end up drawing all our different fields on all our values. Something kind of cool that we want to be mindful of is that when x is 0, all our values are 0. So we'll draw these horizontal lines right here. Except when we're 0 over 0, does that exist? Nope. So we don't draw anything there. So our field on the left side, we'll draw negative 1, 2. So that will give us a negative 1, 1, 2. Something a little more flat. Over here, it's going to be negative 2, 2, which is going to look like negative 1. Negative 2, 1, which is more steep, down 2 over 1, right? And on the right side here, it's going to be negative 1, 1. That's going to give us a nice 45. Okay. Now, that's all the slope fields are. We're just graphing out each of these parts. Okay. Yeah, the homework, I'm figuring that you guys can submit online. If not, we'll keep it and see how much will accumulate. Because if it's 2 weeks, that's not a big deal. But what I'm afraid of is that no one does the homework till the very end, and you guys are so far behind. We're going to do a lot of AP practice material through the AP classroom. So that's all is mostly self-scored, unless if it's like their free response. So you guys will get points that way. But we're really working in March and then April to work for the AP exam. So a lot of this stuff is just practice. We learned most of the material already. So I'm just really just completing the rest of just a couple things that we haven't gone over, and then retouching on stuff once again that we should have went over a little better. Like we did these slope fields and solving general equations pretty quickly in one day, so I'm going over it again, and so we can have homework on it. If I go down, if I go down and look at the answer sheet, our answers look kind of like that. If you notice, when y is 0, they didn't draw anything here, because when y is 0, we're dividing by 0, and that isn't a number. Not a number, right? Okay. All right. I think, so slope fields I think are actually pretty easy. They can get a little tricky when they're asking you to decide, of course, which one of these is the equation. So we'll have a lot more examples of that later when we do some more AP review stuff. Okay, so I think the hardest part right now is us changing this into an x and y problem. Okay, an x and y problem. They didn't give us a particular point, no particular point. So we're going to leave it as a plus c problem at the end. This is why they call this a general solution. Okay, so as you can notice here, let me zoom a little more, that x's and y's are on the wrong side. Well, let's go ahead and ask everyone to move. We're going to multiply dx to both sides, right? That's how we move the dx. And then we're going to multiply the y over here. So e 2 to the y dy is equal to 2x dx. Now for us to get back to our x's and y's, right, we're going to have to integrate to get rid of our dx. So just like in algebra, if I do something to one side, I'm going to do something to both sides. So I'll take the integral, e to 2y dy equals to integral of 2x dx. Do we have an identity that says e to the 2y? The integral of e to the 2y. We don't. So just remember, if we don't have that identity, we have to use u substitution. So if I call u 2y, du is equal to 2 dy. dy is equal to du over 2 by dividing to both sides. So now we have the integral of e to the u du over 2. And can I just write this on the outside to save us some time? And write the 1/2 outside. Equals to, on the right side, remember that's invisible 1 here, and that's a constant of 2. Right, this could be written outside to make your life a little easier. And that's just going to be power rule. So this will be 2 integral of x dx. Alright, now we have, that's in your identity sheet. That's in your identity sheet. This is 1/2 e to the u. We're going to write it this way once. Plus c1 is equal to 2x squared over 2 plus c2. Is everyone okay with that integral? I think it's pretty straightforward. I'm going to go ahead and move the c's over. Minus c1, minus c1. So we'll say C2 minus C1 is equal to C to make our lives a little easier. And we're going to plug in back our U value. And then we say U was 2y. So 1 over 2 e to the 2y is equal to x squared, the 2's divide out, plus regular c. Okay, now we're solving for y. Let me highlight little y here. Whoops. See, we're solving for y, so we get rid of everyone except for y. Opposite, so we gotta get rid of the 2, then we gotta get rid of the e, and then we gotta get rid of this 2. In that order. Okay, the opposite of divide by 2 is multiply by 2. So e2y, darn it, e2 to the y power is equal to 2x squared plus 2c. And then we're going to log both sides. The way we get rid of a e, we log both sides. So natural log ln both sides. Let me use a different color. Natural log both sides, natural log both sides. That's all together. That becomes 2y is equal to natural log of 2x squared plus 2c. Darn it. This is all in the parentheses here. And then we divide the last value by 2. Y is equal to ln natural log of 2x squared plus 2c, all divided by 2. Now the hard part here is to simplify this remainder stuff. Because really, if I look here, isn't that, but we can't even do that. I forgot the parentheses. Now our issue is that you need to know your Algebra 2 log skills. So I'm going to go back up here. Okay? Let's see if we remember our Algebra 2 log skills. And the Algebra 2 log skills is that if I'm adding logs, log ln of a plus, oh no, never mind. We can't do that. I think we're done then. Oops, I forgot the rule. The rule I was thinking about was ln of a plus ln of b is equal to ln of a times b. But that's not this rule here. Okay. Any questions on this one? Let me check the answer. Let's see what they spun around in you differently. No, that's exactly what they wrote. Wait, did they? Oh yeah, that's what they wrote. Oh, I see what they called this guy just C. He said 2 times C is, we'll just call it a constant C. No. I said no. Next question. Okay, so we can try the easy one on the right or the hard one on the left. I haven't done this one in a while. Let's go try it. Number 4. Now, if I'm subtracting logs, exponentials. So here's what we need to remember. Your rules, this guy here, needs to be split because we need the x's and y's separated. If you remember the rule, if I say something kind of lame, 3 squared times 3 to the 5th, what happens to the exponents? Do we add them or multiply? Is it going to be 3, 2 times 5, or 3, 2 plus 5? Well, is it true that I have 10 threes, or is it true that I have 7 threes? This guy, 2 plus 5. If I do the same thing, 3 squared divided by 3 to the 5th, that can be rewritten as 3 squared minus 5. Algebra 2 rule allows us to rewrite this as 3 squared times 3 to the negative 5th power, writing this on top. And then our first rule, when it comes to multiplying powers, gives us this guy here. So this looks super confusing if we don't know our first trick. Our first trick is to split that x and y. So this is dy over dx, and our first trick is to split the e over e to the y. That really is the first trick. If I can do that, now the rest is going to be a lot easier. Now we can separate our function. E to the y is equal to dy is equal to e to the x dx. Is that differentiation? On the right side here, this is just algebra. That's just algebra rules. And the problem is that here is not differentiation. We're trying to integrate. We're trying to go backwards. See, dy dx is already the derivative. And we're trying to look for the particular solution. So, if you guys remember, trying to get rid of dy dx, and I can take the integral of both sides. And this is straight definition, right? Integral of e to the y is just e to the y equals the integral of e to the x is just e to the x. Right, the plus c. Now, they told us specifically that when x is 2, so now everyone look at the top right here, up here. When x is 2, our answer y is natural log e squared plus 2. And actually, this is the time where I like plugging that information here, because I have to figure out what c should be to make this problem work. Since we have x and y, x is 2, y is natural log e squared plus 2, we can just plug it in. So e to the y, which is natural log e squared plus 2, is equal to e to the 2 plus c. On the left side, the natural log and the natural log, oops, sorry, it ran away from me. Oh, it keeps jumping up there. Why does it do that? Oh, I can't do it. Okay, never mind. I can't really hover with this iPad. Okay, So this, right here, that cancels out, or that giving us e squared plus 2 is equal to e squared plus c minus e squared minus e squared. C is equal to 2. Going back, we can now plug it in here. E to the y power is equal to, coming this way, e to the x plus 2. We're solving for a particular solution of y, so we have to get y by itself. How can I get rid of this e? How do I get rid of this e? Add. Okay. We log both sides. Natural log on both sides. I use a different problem. Natural log both sides. Missed it. I'll left with y is equal to natural log of e to the x plus 2. That's it. Let's see. Would this have worked? Remember, we're given this information on top of here. If x was 2, if this was 2, do we end up with the y value? End up with this y value? We do! Now, if you can do this, you guys are in great shape. Is this the hardest problem? No, it's not, but it's a great start of just practicing separating our x's and y's to dx and dy. Then take the integral, practicing your integrals. If you have to use u substitution, you have to plug in your initial condition, and then you have to use some more algebra 2 to get that y by itself. Okay, on this right side, let's go ahead and do this problem on the right. Okay, the idea is y is on one side, x is on the other, right? X is on the other. So everyone's screwed up, you're on the wrong side. Let's separate our variables first. So don't forget when you see problems like this. First step, just get everyone on your right side, on the correct side. So this is going to be dy over square root of y is equal to 3x dx. This is the y. And then I'm going to integrate both sides. To rewrite this, square root of y, that's y to the negative 1/2 power. How you guys with that? Is that okay? Is equal to integral of 3x dx. Well, the right side integral is pretty easy. The left side integral, it's the same as the power rule. We're going to plus 1, negative 1/2, plus 1, right? So it'll be y, less than be y to the 1/2 over 1/2 is equal to 3x squared over 2 plus c. Now again, this is where I like to plug in my x and y value because they're all ready to go. X is 0, y is 1. So if x was 0, if that was 0, and y was 1, we can rewrite this as the square root of 1 over 1/2, which is 2 over 1, is equal to 0 plus c. C is equal to just 2. Let me rewrite the problem. Let me simplify this a little bit. 2 square root of y is equal to 3 over 2 x squared plus 2. We're going to get rid of that 2. and then get rid of the square root. Y is equal to 3 over 4, because we divided both sides by 2, plus 1. And then we're going to square both sides. Sorry, I get disconnected sometimes. Uh-oh. Okay. Any other? Is everyone okay? Is everyone keeping up? Am I going too fast? Okay. Let's move on then. Alright. If you look at number 6, the first of it is what we did before. Right, this is really e to the x over e to the y. This is separatable, right? We separate these both sides. This should be pretty easy. Square root problems. Yeah. Now, the homework that you guys have is just really just working on these problems again. On the College Board website, the free response questions, they're going to look just as difficult as this. Maybe a little more difficult, just a little bit more. But if you got this good start, if you got this, if you understand what we're doing here, separating our variables, making sure dx and dy are on their own side, and you integrate, you're in great shape. Yeah, Charles, just on the side here. So when we have a natural log, ln and e, let's say to the x, this is just x. And the reason why is natural log is log base e of e. And the long way of doing this is we say, hey, the exponent always gets moved down because of logs. So it's x log base e of e. And this guy here is just 1. And we're back up here. So this is the fast motion right here. They'll just cancel out, leaving just the exponent. But this is the reason why right here. And you can do this again with any exponent. If I had 3 to the x plus 2 is equal to, say, 11. I need to solve for x. Get rid of the 2, get rid of the 2. You have to have the exponent by itself. And then I would log base 3 of both sides. And that this goes away pretty much. This is just x. But of course, the fancy long way is that the x goes to the front, and log base 3 of 3 is just 1. So x is equal to log base 3 of 9. And log solve for exponents. 3 to what exponent is 9? That's 2. Let me double check it. If I plug in 2 here on top, 3 squared is 9. 9 plus 2 is 11. Going the other way, if I say e to the ln of x, this also cancels their inverses of each other. That just becomes x. Okay, I posted up the worksheet. Work on this. Tomorrow I'll have the AP Central questions. I'll figure that out. And then there'll be some free response questions part of that AP Central. Do you guys need me to do one more problem, or we're good? Okay. If you want, you can always watch this video again. I'm going to edit so the first 20 minutes are done. No, AP Central will be for tomorrow. or AP classroom will be for tomorrow. Today you have a simple worksheet just like what you guys just saw right here. And some of the problems might repeat, but it's just for you guys to do the same problem again. For this class, I think I'll live stream every day, every A and B day at 1 o'clock. Every A and B at 1 o'clock. The problem is the live stream link changes, so I'll just keep putting that on the announcements at the top of the page, and I'll try to send it out a little early, but the announcement will have that link. Okay, about 1 o'clock. If you guys want me to try the other platforms, I remember I did a poll, and some people said they wanted to try Zoom, and some people wanted to try the Schoology classrooms, and they're both viable. But I think YouTube Live had the most views, and there's no download. Sometimes conferences doesn't necessarily work from your phone. Okay. All right. Thanks.